Good afternoon. I'm Christina Canavesi, president and co-founder of LighTopTech. We're developing a new metrology instrument that's called Explorer 4D that would allow contact lens manufacturers to inspect and fully characterize their lenses in a single-shot measurement through an automated and accurate process. The Explorer 4D will replace the current process for quality control in contact lens manufacturing, which consists of making a series of measurements on different instruments because each instrument can only measure one thing. This is a time-consuming process, it's labor-intensive, it's costly, and it's prone to human error. In contrast, the Explorer 4D will perform the characterization in a single shot, it's just one instrument, and it will drastically reduce handling time. It will ultimately lead to increase in production yield, and it will bring better quality products on the market. So this is how the Explorer 4D works. The Explorer 4D collects a 3D image of the lens, and the lens can be either in air or in solution. And from that image, we can identify if there are any defects or imperfections inside of the material. Additionally, we can extract from the image all the parameters of interest of the contact lens. For example, you can see here a full thickness map, a 3D thickness map of the lens, and a power map as well. Beyond this initial opportunity in metrology for contact lenses and intraocular lenses manufacturing, the Explorer 4D will enable high-definition, volumetric, non-invasive imaging for medical applications. And it will lead to optical biopsy, that is, imaging with cellular definition in real time, in vivo, with no cutting. The Explorer 4D will be used by eye banks to qualify donor corneas prior to transplant, and also by corneal surgeons at the time of the surgery. Compared to existing technologies, the Explorer 4D can provide the cell density at the bottom layer of the cornea over a bigger area than any other product on the market. And since it's non-invasive, the Explorer 4D can also be used by doctors to monitor the progress of their patients in the months after surgery. The Explorer 4D can also be used in dermatology for skin cancer imaging and guided surgery. We recently concluded a clinical study in collaboration with the University of Rochester Medical Center, and we imaged 28 patients who had skin cancer. So LighTopTech was founded in 2013, but our relationship with HTR dates to, quite a few years before that. I took part in the pre-seed workshop in 2011, and then, as Mike mentioned, we all took part in the Innovation Corps program funded by the National Science Foundation, through which we went through training and commercialization at Stanford University. We moved into the University of Rochester Student Incubator at HTR in 2014, which corresponded with our first federal funding from the National Science Foundation, Phase 1, STTR. Beyond that, we received a Phase 2 grant from NSF of $750,000. We've taken part in a number of programs at HTR, including MEP, and we've taken advantage of the first prototype lab, where we've used the 3D printers to build some of our initial prototypes. If you have further questions about LighTopTech, come find me at the reception.